All right, guys. In this next one, we are looking at finding a probability that's bounded between two different x values. So this one, we're always going to start out with a picture. So our variable is still x. Our mean this time is 5. And we are asked about the x values 2 to 9. So 2 is obviously going to be to the left of 5. And 9 is going to be a little farther to the right of 9. So it's 4 spaces away versus 3. So kind of just, the more you draw this to scale, the better it's going to be for your understanding. All right, we are trying to calculate this probability. Now, there's probably a couple questions that are popping in your head, maybe, maybe not. But from these last couple examples, you're going to notice the inequality signs. And the fact that it's less than or equal to or greater than or equal to in certain problems doesn't really matter. It's not going to affect the answer because it's such a minute detail that it doesn't play that big of a factor. And especially since we're rounding to 3 significant figures, it doesn't matter, okay? But we do carry that with our notation all the way through the problem just so it's consistent. So we are exactly answering the question that's given. All right, so second thing that I want to do under my picture is just put the z-scores. And under the mean is always a z-score of 0. Okay, so getting back into this problem, we have to calculate both z-scores. We have to find the z-score for 2 and for 9. Okay, so you can do them in any order. I just kind of go from left to right. So using our formula, you have z is equal to x minus mu, which is the mean, divided by your standard deviation. So if I'm doing 2, let's say, the z-score for 2 would be 2 minus 5, which is our mean, divided by the standard deviation, which is the square root of our variance that's given to us. Okay. Now, if you type this into your calculator, don't worry that you have a square root on the bottom. We don't rationalize it. We get a z-score of negative 1.342. Okay, and that is important, so I'm going to keep it there. And we also want to do the exact same thing for 9. Okay, so we have 9 minus 5 divided by the square root of 5. And that will give us a z-score of 1.789. Okay, so that's important too. I'm going to put those in my table really quick so you guys can see the relationship between negative and positive z-scores. And the negative one is to the left of the mean, and the positive one is to the right of the mean. Okay, and that tells you how many standard deviations you are to the right or to the left of the mean. Okay, so as we are getting into our probability, I always rewrite the question exactly how it's stated. And then I break that apart. So I think about this. What does it mean to find the probability that's bounded between these two areas? And I want you to think about this as finding displacement. It's always your final minus your initial, right? And so in order to figure out the space between this, think about like if you're 9 years old and 2 years old, what's the age between you guys? Well, you would take 9 minus 2 and you would get 7. Well, our answer here isn't 7, but we are going to take that same mindset and do the probability that x is less than 9, and we're going to minus the probability that x is less than or equal to 2. Okay, so what that looks like in a picture is we're finding the entire probability, everything that's to the left of 9, so everything here, and then we are subtracting out this little piece here, which would leave us only with that middle section right there. Okay, I know my animations aren't the best, but it'll do. So once we get that probability broken up, now I rewrite these probabilities, replacing the x with the z-score that it correlates to. So the 9, it's going to be z is less than 1.789 minus the probability that z is less than or equal to, keep in mind we're just using that same notation, equal to, because that's what was in the question. And the z-score for 2 is negative 1.342. Now, anytime we get a negative z-score, we have to change it to a positive. So before I go finding my probabilities, I just rewrite this one more time. And I'm going to change this over here, so I'm using the complement of the positive z-score. So it's 1 minus the probability z is less than or equal to 1.342. So now we're ready to go to that table and find out both probabilities for each of these z-scores. Okay, so let's go here. And the first one that we have to find is 1.789. Okay, so we're looking for 1.78. That was a really weird 89. Okay, so here we go. We got 1.7 right here. 8's right here. So their cross section, 1.78 is right here. And then we need to get the 9 involved. So 1.789, bam, we need to add an 8 to that value. So if you drop the decimal and you think about it like this, 9625 plus that 8, you're going to end up with a probability of 9633, and then you can go ahead and put that decimal right here. Okay, so that's our first probability that we're going to carry through. Okay, now the second one, I'll just switch colors and stay on this table. The second z-score was 1.342. Okay, so 1.3 is right here. 1.34 is right there. I'll switch this up. So we're starting with this value, and we need to add this 2. So that's the second number there. So that probability, we're starting off with 9099, and we are adding a 3. Okay, so that probability turns into 0.9102. Okay, so we come back to our problem here, and we plug those in. So the probability that z is less than 1.789, that probability was 0.9633 minus, this is where we just got to pay attention here, 1 minus 0.9102. And I plugged that whole entire thing into my calculator, and you're going to get a longer decimal than you need, but I always write it out. And then you can round to 3 significant figures. Now, if your value starts with a 0, that 0 is not significant. So it's 8, 7, and then you want to round that one right here to a 4. And that is your answer, guys. Ta-da!